National Electrical Code Table 310.15b6 provides ampacity ratings for service conductors and dwelling units. This table often leads to confusion regarding the use of parallel conductors. The specific question addresses whether parallel 2/0 copper conductors can be used for a 400 amps dwelling service based on the table's allowance of 200 amps for a single 2/0 copper conductor. The answer is no. Parallel 2/0 copper conductors, used as described, are not adequate for a 400 amps dwelling service according to the National Electrical Code. To fully understand this, let's delve into the principles behind conductor ampacity, parallel conductor rules, and how they relate to the National Electrical Code. Firstly, conductor ampacity refers to the maximum current, measured in amps, that a conductor can carry continuously under specified conditions of use without exceeding its temperature rating. The ampacity of a conductor is determined by several factors, including the conductor material copper or aluminum, its size American wire gauge or KC mil, its insulation type, and the ambient temperature where it is installed. The National Electrical Code provides ampacity tables, such as Table 310.15b16, which lists the allowable ampacities for various conductors under specific conditions. These tables are based on an ambient temperature of 30 degrees Celsius, which is 86 degrees Fahrenheit, and no more than 3 current-carrying conductors in a raceway or cable. Secondly, National Electrical Code Table 310.15b6 is a specific exception that applies only to single-family dwellings and the individual dwelling units of two-family and multifamily dwellings. This table allows for smaller service conductors based on the dwelling service size. It's important to note that this exception applies only to the service conductors themselves, which are defined as the conductors between the service point, which is typically the utilities connection point, and the service disconnecting means, which is usually the main breaker panel. The purpose of this exception is to recognize that dwelling loads are often intermittent and not all appliances and devices operate simultaneously at their maximum rated current. This allows for a reduction in the required service conductor size, leading to cost savings without compromising safety. Thirdly, when conductors are installed in parallel, meaning two or more conductors are connected in parallel to form a single electrical path, specific rules must be followed. National Electrical Code Section 310.10h outlines the requirements for parallel conductors. One key requirement is that all parallel conductors must be the same length conductor material, cross-sectional area American wire gauge or KC mil, insulation type, and be terminated in the same manner. This ensures that the current is evenly distributed among the parallel conductors. Another crucial requirement is that the parallel conductors must be sized such that the combined ampacity of all parallel conductors is equal to or greater than the rating of the overcurrent device protecting the circuit. In the context of the question, Table 310.15b6 allows a 2/0 copper conductor to be used for a dwelling service up to 200 amps. This does not automatically mean that parallel 2/0 copper conductors can be used for a 400 amp service. To determine if parallel 2/0 copper conductors are suitable, we need to consider the ampacity of 2/0 copper under normal conditions, as listed in Table 310.14b16. For a 2/0 copper conductor with a typical insulation type such as THHN or XHHW, the ampacity is typically 175 amps when operating at 75 degrees Celsius. If two 2/0 copper conductors are run in parallel, their combined ampacity would be 175 amps plus 175 amps, equaling 350 amps. This is less than the required 400 amps for the service. Therefore, parallel 2/0 copper conductors are not sufficient for a 400 amps dwelling service. Furthermore, it's important to consider adjustment and correction factors that may further reduce the allowable ampacity of the conductors. Adjustment factors are applied when there are more than 3 current-carrying conductors in a raceway or cable. Correction factors are applied when the ambient temperature is higher than 30 degrees Celsius. These factors reduce the allowable ampacity of the conductors to ensure that they do not overheat. In a given scenario, even if the ambient temperature is within the specified range and there are no more than 3 current carrying conductors in the raceway. The parallel 2/0 copper conductors still do not meet the minimum ampacity requirement of 400 amps. To provide a 400 amp service, larger conductors would be required. For example, one could use parallel 4/0 copper conductors. According to Table 310.15b16, a 4/0 copper conductor with THHN or XHHW insulation has an ampacity of 230 amps at 75 degrees Celsius. Two parallel 4/0 copper conductors would provide a combined ampacity of 460 amps, which is sufficient for a 400 amp service. Alternatively, one could use a single conductor with an ampacity of at least 400 amps. According to Table 310.15b16, 500 kcmil copper conductor with THHN or XHHW insulation has an ampacity of 380 amps at 75 degrees Celsius, which is not sufficient. A 600 kcmil copper conductor with THHN or XHHW insulation has an ampacity of 420 amps at 75 degrees Celsius, which would be sufficient. It is important to emphasize that these are just examples, and the specific conductor size required will depend on the specific installation conditions, including the ambient temperature, the number of current carrying conductors in the raceway, and the type of insulation used. When installing parallel conductors, it is essential to ensure that they are properly sized, installed, and terminated. The conductors must be the same length, material, size, and insulation type. They must also be terminated in the same manner using appropriately sized connectors. Proper installation practices are critical to ensure that the current is evenly distributed among the parallel conductors and that the conductors do not overheat. In summary, while National Electrical Code Table 310.15b6 allows for smaller service conductors in dwelling units, it does not override the basic requirements for conductor ampacity and parallel conductor rules. Parallel 2/0 copper conductors are not sufficient for a 400 amps dwelling service because their combined ampacity is less than 400 amps. To provide a 400 amp service, larger conductors, such as parallel 4/0 copper conductors or a single 600 kcmil copper conductor, would be required. It is always recommended to consult with a qualified electrician or electrical engineer to ensure that the electrical system is designed and installed in accordance with the National Electrical Code and local regulations. This will help to ensure the safety and reliability of the electrical system. Also, remember that the exception in 310.15b6 only applies to the service conductors and not to feeder conductors within the dwelling. Feeder conductors must be sized according to the general ampacity rules in Table 310.15b16. Failure to comply with the National Electrical Code can result in electrical hazards such as overheating, fires, and electrical shock. It is important to prioritize safety and follow all applicable codes and regulations when working with electricity. In addition to the National Electrical Code, local codes and regulations may also apply. It is important to check with the local authority having jurisdiction to determine any specific requirements for the electrical installation. By understanding the principles behind conductor ampacity, parallel conductor rules, and the specific requirements of the National Electrical Code, one can ensure that the electrical system is designed and installed safely and correctly. Remember to always consult with a qualified electrician or electrical engineer for assistance with electrical installations.